A refrigerator-sized machine in New York is doing something that sounds fake. It pulls air into a box, adds water, runs on clean electricity, and out the other end comes real gasoline. Not hydrogen. Not biodiesel. Not some experimental gel you've never heard of. Gasoline. The kind you pour into a normal car and drive. But here's the part most headlines skip. The machine works. The real question is whether it can ever make enough fuel to matter. And the strangest part is, the most important number about this machine is not how advanced it is. It's how little fuel it actually makes. The company is called Aircela. They're a small startup based in New York. Not one of the giant oil companies. Not a massive refinery project. A small team trying to shrink fuel production into a modular machine. And before you write that off as science fiction, you should understand the problem they're actually trying to solve. Because it's not the one you think. Everyone assumes the future is electric. Tesla, Rivian, battery breakthroughs every other week. And yeah, EVs are growing fast. But here's a number most people haven't sat with. There are over 1.4 billion combustion engine vehicles on the road right now. Not million, billion. And transport still relies overwhelmingly on oil-based fuels, over 90% according to most major energy estimates. Swapping all of those engines for electric ones would take decades. Not because we don't want to, because factories can only build so many EVs per year. Charging infrastructure is still years behind in most countries. And some vehicles, heavy trucks, container ships, aircraft, farm combines, are much harder to electrify, not impossible. But the weight, the range, the charging time, the energy density, those problems don't have quick answers yet. So the world is stuck in a gap. We know fossil fuels are the problem, but we can't replace every engine fast enough. And here's what almost nobody talks about. The real enemy is not the engine, it's the fuel supply chain, the drilling, the refining, the pipelines, the tanker ships crossing oceans, the trucks hauling fuel across continents. The infrastructure that moves liquid energy from deep underground to your gas tank adds cost, emissions, risk, and fragility before the fuel is even burned. Aircela's bet is simple. What if the fuel didn't have to travel at all? Here's how their machine works, and it's simpler than you'd expect. Step 1. Fans pull in regular ambient air. A chemical process strips the carbon dioxide out of it. That CO2 becomes the carbon source for the fuel. Step 2. The machine splits water into hydrogen and oxygen through electrolysis. That hydrogen becomes the energy carrier. Both steps are powered by renewable electricity, solar, wind, whatever's available on site. Step 3, and this is where it gets interesting. The system combines the captured CO2 and the hydrogen to produce methanol, a simple liquid alcohol. Then it converts that methanol into gasoline using a process called methanol to gasoline synthesis, MTG. It's not some experimental lab trick. Exxon helped develop this technology back in the 1980s. New Zealand ran an entire MTG plant in the mid-80s producing 14,000 barrels a day. The chemistry is proven. It's been road tested for 40 years. What's new isn't the reaction, it's the size of the machine running it. Traditional synthetic fuel plants are enormous. Billion-dollar facilities, pipelines, refineries, years of construction before a single drop of fuel comes. Aircela threw all of that away. Their system is modular, compact. You don't build a plant. You place a machine. A remote mining site in northern Canada. A military outpost with no pipeline access. A farming operation 60 miles from the nearest gas station. An island community running diesel generators that cost a fortune to resupply. The machine sits on site and makes fuel right there. No tanker trucks, no shipping emissions, no supply chain to break. The fuel doesn't travel. That's the point. But here's where the headline starts to crack. Because there's one number that changes how you think about everything you just heard. According to Aircela's own published information, a single machine is designed to capture and convert about 10 kilograms of CO2 per day and produce roughly 1 gallon of gasoline. 1 gallon per day. The average American driver uses around 500 gallons a year, so one machine can't even keep one car running full time. That sounds like a deal breaker. It's not. But here's the uncomfortable part. If your goal is to power a normal car with this, the machine is almost useless. If your goal is to replace a fuel truck in the Arctic, it suddenly becomes very interesting. Aircela isn't targeting your garage. They're targeting locations where fuel delivery itself is the biggest problem. When you're airlifting diesel drums to a mining camp above the tree line, or shipping fuel barrels to a Pacific island, you're already paying $5, $8, sometimes $12 a gallon just for transport and logistics. In those situations, making fuel on site, even slowly, even 1 gallon at a time, starts making real economic sense. The machine doesn't need to outproduce a refinery. It needs to outperform a helicopter carrying fuel drums. That's a very different competition. Now the fuel itself is worth talking about. Regular gasoline from a refinery carries sulfur, which creates smog and acid rain. It contains ethanol, which can corrode older engines and lower fuel efficiency. It carries trace heavy metals left over from crude oil processing. Aircela says their synthetic gasoline contains none of that. According to the company, it's cleaner burning and compatible with any existing combustion engine. No modifications needed, no special parts. You pour it in and it runs. And then there's the carbon question. When this fuel burns, it releases CO2. That's just chemistry, you can't avoid it. But here's the distinction. That carbon was already in the air. The machine captured it to build the fuel. So when it burns, it's returning carbon that was already circulating. Not releasing ancient carbon that's been locked underground for millions of years. In theory, the net addition to the atmosphere is close to zero. But in this matters, that's only true if the electricity powering the machine comes from clean sources. It is not magic. It is only close to carbon neutral if the energy running the system is genuinely renewable. Plug this machine into a coal-powered grid and you're just adding steps between the coal and the tailpipe. The carbon neutral claim lives or dies on the energy source. And this is where even supporters of the technology have to admit something uncomfortable. If you use this fuel in the wrong place with the wrong energy source for the wrong application, it makes almost no sense. So why not just skip all of this and use electricity directly? Charge an EV. Cut out the middleman. It's a fair question, and honestly, it's the strongest criticism of the entire concept. Charging a battery with renewable electricity is roughly 3 times more energy efficient than using that same electricity to make synthetic fuel. You lose energy at every conversion step: electrolysis, synthesis, combustion. By the time the gasoline moves the car, most of the original electricity has been wasted as heat. If you can plug in, you should plug in. That's just physics. But that's the whole point. Some machines can't plug in. A fishing trawler 200 miles offshore can't plug in. A wildfire helicopter can't plug in. A backup generator at a rural hospital during a hurricane can't wait for a charging station. The real enemy was never the engine. It was always the supply chain feeding it. These machines will burn liquid fuel for decades. The only question is where that fuel comes from. Aircela now says it's targeting limited commercial availability in select U.S. markets starting in late 2026. They're beginning with commercial and industrial clients, off-grid operations, remote facilities, emergency preparedness. If those first units deliver on their promise, the company will scale from there. Smaller units, higher output, lower cost per gallon. That's the roadmap. And it will take time, a lot of time. Nobody is pretending otherwise. 100 years ago, gasoline came from holes drilled deep into the earth. Aircela is betting the next version comes from the air above our heads. Not because it's cheaper today. Not because it can replace oil tomorrow. But because for the first time in a century, someone built a machine that proves gasoline doesn't have to begin underground. And once you prove something is possible, the only thing left is making it practical. That part has never stopped engineers before.